demands. Demand for these super stuffed bars has skyrocketed by 400% in 6 months. To keep up,
It begins 4,000 miles away. For the Dubai bar, we require fine flavor cacao, specifically the Arriba Nacional variety from Ecuador.
Logistics are the first hurdle. These beans arrive in 60-kilogram jute sacks. But before they can become luxurious,
this is the destoner. It uses a specific frequency of vibration combined with an upward airflow. Gravity does the rest. But the invisible enemy is moisture. The beans must sit between 6.5 and 7.5% water content. Cleared for processing, 3 tons of beans are lifted to the roasting silos every hour. They are about to face temperatures of 140 degrees. Once roasted and ground into liquor, we have liquid chocolate. But if we simply cooled this liquid now, the result would be disastrous.
Einstein.
To force the molecules into form V, the chocolate enters the continuous tempering machine. It's not just a heater, it's a precision thermal gauntlet. The process, we heat it to precise dance. To eliminate the unstable crystals, we apply shear force. Rotating scraper blades smash the chocolate against the chilled walls and mix it aggressively. To eliminate the unstable crystals, we apply shear force. Rotating scraper blades smash the chocolate against the chilled walls and mix it aggressively.
Days. Before a single drop enters a mold, we test. A temperometer analyzes the cooling curve.
Now, the chocolate is physically engineered. It is ready to become the vessel. But a shell is nothing without its heart.
Home cooks pan fry this with butter, but for a factory producing 10,000 bars a day, we need consistency.
Here, chemistry takes over. We are inducing the Maillard reaction, a chemical bond between a
but we have a problem. To get the crunch, we used fat. If we put this oily pastry directly into the chocolate, the excess oil will migrate.
The solution is centrifugal de-oiling. We spin the batch at 800 RPM. This mimics a salad spinner.
The pastry is now hygroscopic. It wants to absorb water. We must seal it in the pistachio cream immediately. The clock is ticking. While the pastry cools, we process the green gold. For the authentic Dubai flavor, we use high-fat pistachios, often sourced from Bronte or Antep.
First, a coast grind breaks the cellular structure, but this texture is still sandy, about 500 microns in size.
Enter the ball mill. Inside this chamber, thousands of hardened steel beads are agitated at high speed. The target is 20 microns. Why? Because the human tongue can detect distinct particles above 25 microns.
Or clanchins, the friction generates immense heat. If the paste exceeds 55 degrees, the proteins denature and the flavor burns.
Finally, the emulsion. We blend the nut paste with white chocolate for sweetness and tahini for stability.
Now, the two worlds meet. The liquid pistachio cream and the brittle, dry kunafe.
The biggest risk is water activity, or awe. If the pistachio cream contains even a trace of moisture from low quality.
This is why our cream is fat-based, utilizing cocoa butter and nut oils. It is hydrophobic.
Standard high-speed mixers would pulverize the fragile pastry into dust. We must use a Sigma blade mixer.
The result is a matrix with incredibly high viscosity. It resists flow. This makes it difficult to pump, but perfect for eating.
Moving this heavy mass to the molding line requires a lobe pump. Unlike gears that grind, lobes create large... The filling is ready. But the chocolate shell is waiting on the line. Now, we must assemble the bar with robotic precision. The assembly begins with the mold. We use high-density polycarbonate. It is expensive, but it has a specific thermal conductivity.
First, we flood the mold entirely. But we don't want a solid block of chocolate. We need a hollow vessel. To achieve this, we use gravity.
The machine inverts the molds.
90% of the chocolate pours back out to be recycled. What remains clinging to the walls creates the shell.
Once the shell sets, the filling begins. Because our mixture is packed with crunchy pastry, standard nozzles would clog instantly.
The filling is full of trapped air pockets. If left alone, these become breeding grounds for bacteria or cause the bar to weigh less than the label claims.
Finally, the bottoming station seals the tomb. A final layer of chocolate covers the filling, and a heated scraper.
We have built the bar, but it is soft, warm, and unstable.
You cannot simply put chocolate in a freezer. If you cool it too fast, unstable crystals form, and the cocoa...
The tunnel is divided into 3 zones. Zone 1 is radiation cooling. We use cold plates without air movement.
Zone 2 is the powerhouse, convection cooling. Chilled air at 12 degrees Celsius is blasted over the molds.
This is the critical moment, contraction. As Form V crystals build a tight lattice, the chocolate physically shrinks by about 2%.
In Zone 3, we actually warm the chocolate slightly before it exits. If the bar comes out at 10 degrees...
The molds are inverted. The contraction has broken the vacuum seal, but the heavy bars are still holding on by friction.
A pneumatic hammer delivers a calibrated strike. Not too hard to crack the shell, but hard enough to release the bar.
In a factory full of moving steel gears,
The line automatically rejects it. There is no human hesitation. The risk to the consumer is too high.
These bars are dense. For the premium market, we go further. X-ray scanners density map the filling. They confirm the distribution of whole
Batch samples are taken to the lab for forensic analysis. This is a texture analyzer. It measures the force required to break the bar in newtons. We are looking for a brittle fracture. If the chocolate bends before breaking, the tempering was a failure. We need a sharp, clean...
Finally, the visual inspection. The shell must be uniform, 2 millimeters thick on all sides. The pastry must be...
Agents. Approved batches are laser etched. This code tracks everything back to the specific farm in Ecuador and the specific harvest of pistachio.
We use a cold seal adhesive technology. Standard heat sealing could melt the chocolate during packaging.
Instruments.
Because this bar contains fresh pastry, we employ modified atmosphere packaging. Just before the seal closes, we flush the pouch. Manual packing is impossible at this speed. We deploy Delta robots. Using vision systems, they identify the golden. Simultaneously, the carton erector builds the housing. Hot melt glue is applied at 180 degrees Celsius to seal the flaps in.
A final layer of shrink film provides tamper evidence and a second moisture barrier. The product is now hermetically sealed again.
One by one, the boxes become pallets. Each pallet weighs 800 kilograms, a fortune in chocolate. The final challenge is the environment itself. Outside these walls, the Dubai desert is 45 degrees Celsius.
The pallets enter a reefer, a refrigerated container acting as a mobile fridge. The set point is locked at... Trust is not enough. We insert a USB data logger into random boxes. This device records the temperature every minute of the cargo travels through one of the hottest landscapes on Earth. Inside the steel box, it is an eternal spring. Outside, it is an oven.
For urgent global demand, sea freight is too slow. The bars are air-flown. They move from the factory to the consumer in less than...
From a raw bean in Ecuador, to a pistachio orchard in Sicily, to a high-tech factory in the desert, it is a triumph of chemistry, engineering, and logistics.